Hey, so today we're going to solve quadratics by square roots and then solve by completing the square. So square roots is actually is the most basic version. However, you have to be very careful because the only way you're going to use square roots in the sort of simple form that we're going to do first here is if you're missing that bx term. So all you have is x squared and no x term. So we have a coefficient here and a constant here, and therefore we can solve by isolating the x squared. So if we're looking at example 1 here, notice there's no x term. So isolate x squared means that you are going to add the c value to the other side, and then you're going to divide by a, or the coefficient of x squared. So divide by 2, divide by 2. So now I have x squared is equal to 16. Okay, so that's exactly what this is here, is negative c divided by a. So negative c is positive 32 divided by a, and I get 16. Now, what that does is allow you to take the square root of both sides. You do have to be very careful, however, that you do plus or minus. Okay, because when you're talking about x squared here, you could do a positive 4 times a positive 4, which is positive 16. You could also do a negative 4 times a negative 4, which is also positive 16. So you just have to be very careful that when you do these, you square root both sides, but that you do plus or minus. You are going to get two answers. So square root of x squared is x. And then we have the positive and negative square root of 16, which is positive or negative 4. And you can write your answer just like that. Okay, so for number 2, why don't you pause and try number 2 on your own. Okay, welcome back. So what we are going to do here, again, get x squared by itself. Well, the 30 has already been moved over. So subtract the 30, you get negative 30. So we're simply going to divide by negative 10. And again, the only reason we can do this is because there is no x term to deal with. So now I have x squared, and then negative 30 divided by negative 10 is 3. And then you're going to do the square root of both sides. And plus or minus square root of 3. 3 is not a perfect square. This is an irrational number, so we would get a decimal that went on forever. So we are going to start getting used to the fact that we're going to leave this answer as simply plus or minus root 3. Do not find a decimal answer. This would be the exact answer. The decimal answer would be an estimation. Okay, number 3. So looks pretty basic, right? We're going to subtract 25 from both sides. We are going to square root both sides, making sure we do plus or minus the square root of negative 25. Okay, and then this is x. Okay, we have a problem. Because when you're solving this, you need to have the same number multiplied, so like 5 times 5, but that's a positive 25, not negative. Or negative 5 times negative 5, but that's also a positive 25. So this is actually a no solution problem for geometry. When you do this in algebra, you could do imaginary numbers. So officially, you would say plus or minus 5i. But for our purposes in geometry, we're really not going to have to deal with that. Okay, so just realize that that can happen. But for us this year, we are not going to deal with that at all, which is a relief. Okay. Completing the square. So this is actually a pretty complex process that you should have done last spring. We are not totally sure that your teachers probably got to it, but we are going to go through it because it is important for you to know how to do this for next year. Okay, so completing the square. So we're starting with ax squared plus bx plus c equals 0, just like a normal quadratic equation. So completing the square seems very complicated here. When we go through the examples, you'll see that it's really not that bad. But the big idea is that if you can get one of the sides into a perfect square binomial, so something that looks like this, then you can solve by square roots. Okay, in order to do that, you are going to isolate the x squared plus bx part of it, and then you're going to add b over 2 squared. And what that does is actually complete the square so that you can factor it into this perfect square form. Okay, then you're going to be able to do square roots on both sides. So like the quadratic formula, completing the square solves any quadratic. So that's a really big advantage. And in fact, completing the square is how you come up with the quadratic formula. So how you derive the quadratic formula is actually using complete the square. Okay, but as a warm-up, what you are going to do before we do completing the square is you're going to solve the following examples using square roots. So these look funny, but I will just give you the hint, you are not going to FOIL because this is already in a squared form, which means that I can square root both sides. Okay, so what that looks like here, I'll do the first one with you and then I'll have time for you to try the second one. So what that looks like is I am going to square root both sides. So I have this, and then of course I have to do the plus or minus, like that. Well, this square root will cancel out the squared since the entire side of this equation is being squared. So I end up with x minus 1 is equal to, and then I simplify this to 6. Now I'm going to add 1 to both sides. We generally put that 1 in the front. So you end up with 1 plus or minus 6, and then 1 plus 6 is 7. 1 minus 6 is a negative 5. So my answers using square roots is 7 and negative 5. Okay, hint, example 4 should be integer answers, so these are integers. And then example 5, you will actually have that square root in the answer. So pause for a second and try example 5. Okay, welcome back. So hopefully you recognize that we need to have the squared piece by itself first. So you are actually going to divide by 4 on both sides first. Okay, so that gives us x plus 3 squared, and then I have 5 fourths. Okay, so now this entire side is squared, so therefore I can square root it. To simplify, this is going to be again plus or minus square root of 5 over 4. Okay, those cancel. We end up with x plus 3. Okay, square root of a 5 fourths. So off to the side here, this is the same as saying plus or minus the square root of 5 over the square root of 4. So square root of 5 is not simplifying, but square root of 4 does. So we end up here with plus or minus square root of 5 over 2. Okay, then you're going to subtract 3 from both sides. So subtract 3, and then plus or minus square root of 5 over 2. Now, that looks like a crazy answer, but as you get into more and more complicated math, your answers might get crazy. So there's that. Okay, good. So next, we are going to go through the process of completing the square. All right, so what we're looking at here is we're going to solve the equation x squared equals 8x minus 15 by completing the square. So the first step in doing that is you want to get x squared plus bx by itself. Notice this is a different first step than any other method. Okay, so what we have to do is subtract 8x from both sides. Subtract 8x, and you end up with x squared minus 8x equals 15. What we are going to do is then, notice this is just a number. Don't be afraid that's a negative right now. We are going to take this binomial, x squared minus 8x, and we are going to complete the square. Okay, and we're going to get it back into this form here from like example 4. The point of this is to get it into this perfect square binomial. Okay, so in order to do that, you are going to add b over 2 squared to both sides. So in this particular case, you have b is -8. So -8 over 2 is -4. -4 squared is equal to 16. So I'm going to take that 16 and I'm going to add it to both sides so that it does not change the value of the equation. So now I have x squared minus 8x plus 16, and then the other side, -15 plus the 16. So just adding 16 to both sides. Okay, notice that that allows us to factor the left side into a perfect squared or squared binomial. So 16 is a perfect square, and you can get -4 times -4, and that combined like terms would be a -8. Okay, so this factors into x minus 4 squared, or in other words, if you want me to write it out, it factors into x minus 4 times x minus 4. Okay, so once we have that done, then you can solve by square roots. So the point of completing the square is to get it into this form of x minus 4 or x plus whatever squared equals a number, and then you can go through the square roots process. All right, so you're going to square root both sides with the plus or minus. Simplify. Square root of 1 is 1. Add the 4. Split it up into 2, and then you're in good shape. Okay. Also, since we have integer answers, that could have been factored to solve. All right, let's try one more. So, solve by completing the square. This one is a little rough. Okay, the use of fractions does make things a little harder. But I need you to use fractions. It's important that you are able and fluent in fractions. So get as far as you can on your own, then press play. So press pause and get as far as you can. Okay, welcome back. So you want to first set it up so that we have it in the correct starting form. We're going to add x to the other side, and then we are going to add 7 to the right. Okay, so you want the ax plus bx, or ax squared plus bx by itself, and then the c moved over to the other side. Okay, good. So here we are going to add, remember from our steps, you need to add b over 2 squared to both sides. So in this case, the b is a 1. So we are going to add 1 over 2 squared to both sides. So here I get x squared plus x plus 1/2 times 1/2. So let me do that off to the side. 1/2 times 1/2 is 1 times 1 on top is 1. 2 times 2 on the bottom is 4. So you're adding 1/4. And same over here. Okay, so now this factors. Now, don't freak out with the fractions. It's kind of an easy factoring. Whatever's in the parentheses here is actually the number that goes here. And it's positive b, so you have a positive there, and that's it. You don't have to think about it too hard. Okay, over here, we are going to get a common denominator. So to get this into fourths, this is going to be 28 fourths is 7 plus 1/4. Okay, so now square root both sides. You get x plus 1/2 equals these two together. That's going to be 29 fourths. Okay, and then this is going to be plus or minus the square root. Looks pretty ugly, but it's still very doable. Now we're going to subtract 1/2 from both sides. So I end up with -1/2 plus or minus the square root of 29. And then remember, we can simplify square root of 4 to be 2. So this is a perfectly fine answer. You could also write it like this. And these are common denominators. Notice that looks just like a quadratic formula answer. Okay, good luck.